Next live stream on covering our homework for analytic trigonometry. And basically, this is going to be the first section in our chapter on analytic trigonometry, where we're going to cover just simplifying identities. So this is also my first live stream of 2019 that I'm very excited to get started with. And just want to let you guys know that I will continue doing these live streams covering homework that's going on in my classes, so you guys can kind of follow along. A couple things, I'm going to work through these problems as far as kind of like a free response, show my work, and then what I'll do is I'll take a quick little break in there, and then I will come back through and go go through the multiple choice questions. So if you would like to kind of see more of these videos, if I'm not covering a topic that you are interested in or something you want to see, what I'm going to be, covering previously, or what I've already covered, or what I've previously already covered or going to be covered, I believe in the description I've now added the playlist to my homework as well as my quiz answers. And then also, if you would like the access to my quizzes as well as the answers written down so you don't actually have to watch the video every time, I have that link to my membership, the YouTube kind of join membership, that you can kind of get access to those documents as well. So that's where everything stands now, and let's go ahead and get into the cosecant. Let me just make sure my stream health is showing that it's not perfect. So let me just do a quick little check here. Yeah. Let me change this here real quick. All right. Hopefully that will help out the stream. All right. Hey, Ava. Hey, Alex. How are you guys doing? Well, happy to help your grade. Hopefully you guys will get some benefits, from going through identities. Or if not, just happy to check in with you guys, during my midstream. So happy to save your grade, whatever I can do. Be there for you guys. And I appreciate it. I know I'm doing a little bit earlier live stream. I was going to do a later live stream, but I have been my wife is not going to be, she is out of town this week, so I have the kids all to myself, and what that means is I am going to be very busy after school, or once I get home. So I was like, you know what, I might as well do this live stream now, because I'm going to be so tired, and then I'm going to be like, I told my kids I'm going to go live and do the homework, and then I'm going to be too tired to do it. So I was like, you know what, might as well just knock it out. No more procrastination. So, all right, I'm going to get through this, and then again, of course, I'll go ahead and take a break. Hopefully everything is, it looks like my live stream feed is that worked. So hopefully that's coming in a little bit better and stronger now. All right. So let's get into the first one. Again, this is just a review from the homework. So we've already kind of covered identities, at least the basic ones from quotient, reciprocal, even, odd, cofunction, as well as Pythagorean. So obviously on the notes, you'd want to have access to those so you can do them. I'm basically just going to show you, what we can do, how we can rewrite this. So immediately whenever I see the pi halves minus theta, I'm thinking the cofunction identity. And remember, the cofunction identity is basically like a transformations of your function, like transforming one graph to another. And we know that the cosecant graph can be transformed to the secant graph, and because those are cofunctions of one another. So I can just rewrite this as the secant. Don't know what happened there. Stop. Okay, let's try this again. So the cosecant of pi halves minus theta, based on the cofunction identities, is secant of theta. Actually, let's just use secant of theta. And then we can just rewrite cosine as cosine of theta. All right. Now, if I want to kind of rewrite this, you can think about this, and a lot of times to simplify this, it's helpful to look at things in terms of sines and cosines. So I can rewrite secant, as 1 over cosine of theta divided by cosine of theta. And therefore, if I wanted to simplify this just so it's like as one fraction, I can multiply by 1 over cosine on the top and the bottom. That would eliminate my cosine. That would eliminate this as my denominator. But now that would make it have 1 over cosine squared of theta, which can be simplified into secant squared of theta. And I'll just put a box over around it just because I know, just so we can kind of see what the simplified version. Actually, you know what? Let's forget about the box. Let's just rewrite that as secant squared of theta. Okay. All right, so the next one is doing our even and odd. Looks at least do some even and odd functions, or identities, I'm sorry. That's going to be taking the negative angle. Remember, all of our trigonometric functions are odd except for cosine and secant. So therefore, when you're taking the tangent of a negative angle, that's always going to equal a negative tangent of x. However, more importantly, I'm going to kind of move along here is we also can look into, what other identities could we apply here. We see that I have a 1 minus cosine squared of x, and remember that's part of our Pythagorean identity, which is, cosine squared of x plus sine squared of x equals 1. So if I subtract a cosine to the other side, I can see that sine squared of x is equal to 1 minus cosine squared of x. So what I'm going to do here is to kind of simplify this, I'm going to write everything in terms of sines and cosines. So I'm going to take this, sine is going, our tangent is sine of x over cosine of x. Then we have times sine of x. And then we wrote this as sine squared of x. Okay, so you can see again we have fractions within fractions, and that's kind of the nice thing about when you convert things to sines and cosines. You can kind of get this like larger view as far as what do we want to do to be able to simplify this. Well, there's a couple different things we can do, but if I wanted to get rid of this sine squared in the denominator, then I could just multiply by 1 over sine squared of x. And you can see here that these two will multiply to give me sine squared anyways. So therefore, those divide out, and again, I'm just going to be left with a negative, don't forget the negative, 1 over cosine of x, which is equal to a negative secant of x. Okay. Let's see, working on the next problem is I have 2 cosecant of x divided by tangent of x times secant of x. And again, just when we were doing these basic operations, a lot of times the easy way to kind of look at this is just to write everything in terms of sines and cosines. So cosecant is going to be 1 over sine. So actually I'll just write that. Yeah, I'll write it like this. That does not look like that. 2 times 1 over sine of x. Remember, tangent is sine of x over cosine of x. And secant is 1 over cosine of x. How many of these fractions? Maybe just have one fraction so we can get one trigonometric term. And because obviously that is our directions here, is you simplify, use our identities to simplify so we get it as to one trigonometric function or number. So, first thing that I look at with this is, sorry, it looks like, I don't know what it is with my internet at school, but this is the last time I think if I remember I did live, it kicked me off again. So I apologize for that. For you guys, hopefully the connection will pop soon back for you guys rather shortly, and then you guys will be able to get resumed. So I caught up on my eye. I don't think you guys missed too much, but I was just finishing up this example here, and going from there. So we have cosine squared of x divided by sine of x. Okay, and then when we multiply that through, we get 2 cosine squared of x over sine squared of x. Well, cosine over sine is based on the quotient identity is going to be cotangent. So cosine squared over sine squared is going to equal a 2 cotangent squared of x. Did I show this other one? No, I didn't. So let's write that in there. Negative secant of x. All right, last one. So remember, cofunction identities are transformations, basically, of the graph. So if cosecant goes with secant, and tangent, if you apply transformations to the tangent graph, you're going to get cotangent. So cosine is going to go with sine. So what I'm going to do is I'm just going to rewrite this as sine of theta. So cosine, using our cofunction identities, Even odd identity, sine is odd, so therefore that turns into a negative. Basically, that's a -1 times my sine of theta. And then secant squared minus 1, we got to remember our trigonometric identities. Now, remember cosine squared of theta plus sine squared of theta equals 1. I think that's the easiest one to remember. Now, if we want to get secant, basically all we simply need to do now is just divide by, if we divided everything by cosine. Cosine squared of theta, cosine squared of theta, cosine squared of theta. We would get 1 plus tangent squared of theta equals secant squared of theta. So hopefully within time, within practice, you'll get to the point where you are very comfortable with, knowing that identity. But anytime you get stuck, I just like to use the basic sine squared plus cosine squared equals 1 and then divide that by either sine or cosine to get my other identity. So therefore, if I was to subtract the 1 on both sides, you can see that secant squared of theta minus 1 is going to equal tangent squared. All right, so let's go ahead and simplify this a little more. Sine squared times sine, sine times sine is sine squared times a -1. So we have a negative sine squared of theta divided by tangent squared, which remember is sine squared of theta divided by cosine squared of theta. So again, if we want to get rid of these fractions, we can multiply here by the reciprocal, which is really going to be cosine squared of theta over sine squared of theta, cosine squared of theta divided by sine squared of theta. Remember, this is technically in the numerator of there. That obviously multiplies to 1. And then here, my sine squares divide out, and we'll just be left with a negative sine squared of theta. Okay, so these were some problems. You can see they're not separate. It's just multiplication and division, okay? So when you're trying to simplify some identities using multiplication and division, make sure you're familiar with the cofunction identities, even, odd, as well as Pythagorean. Obviously, you can see these terms are separated by subtraction, but really once you convert them using Pythagorean identities, it's all addition and subtraction. Multiplication and division. Now what we're going to do is just go ahead and simplify using some operations such as multiplying, factoring, and adding and subtracting. All right, and then so these are not always going to simplify to a single trigonometric expression or number, but sometimes they do. So we're just going to really just want to practice on doing some operations that we're used to with numbers and variables and now apply them to our trigonometric functions. All right, so the first one is sine of x minus cosine of x. And just remember, guys, this is, when you have something, a binomial squared, this is going to represent the sine of x, minus cosine of x times sine of x plus, no, not sine of x plus, I don't know where. We were doing difference of two squares earlier today, so I guess I was stuck on that. But it's the product. It's sine of x minus cosine of x times sine of x minus cosine of x, right? Don't just distribute the square. You can't do that. Because what's important here is you got to apply distributive property. So we have sine times sine of x. Sine of x times sine of x is sine squared of x. Sine times negative cosine of x is going to be a negative sine of x cosine of x. Negative cosine of x times sine of x is a negative cosine of x sine of x, and then we have a negative cosine of x times negative cosine of x is a positive cosine squared of x. Now again, remember, orders does not matter. 2 times 3 is the same as 3 times 2. So these are like terms, so I can combine these. And then also remember that sine squared plus cosine squared is equal to 1. So I can rewrite this as 1 minus, and now since I have 2 of these, just like x times x is x squared and x plus x is 2x, well, sine of x times sine of x would be sine squared of x, right? And sine of x plus sine of x is 2 sine of x. So therefore, when I add negative sine of x cosine of x and minus cosine of x sine of x, that's going to be 2 sine of x cosine of x. That goes to 1, and then these two combine to give you right there. Okay, so that would be your simplified version. That'd be great. Thank you. So, yeah. For the next one here is we can see that these have some stuff in common. You, by looking at these expressions, we have two expressions that are separated by subtraction, and you can see that they both share a tangent of x. So typically when things share something, you have something that you can factor out, right? So here we can factor out a tangent squared of alpha. And by factoring out a tangent squared of alpha, I'm left with a cosecant squared of alpha minus 1. All right, well, if I wanted to kind of further look at this, I could say, well, you know, let's see, using our Pythagorean identities, what can cosecant squared of alpha minus 1, what does that represent by using my Pythagorean identities? Now, you could go through these identities and divide everything by sine now. And if you were to divide everything by sine, you would get cotangent plus 1 equals cosecant. So when you subtract a 1, you can see that this is actually equal to tangent. So we'd have tangent squared of alpha times cotangent squared of alpha. And using the reciprocal identities, you understand that these are reciprocals of one another, so therefore they'd multiply just to give you 1. The next one is adding and subtracting, and you know we did verifying identities today. And so one of the big important things, remember guys, when you're combining fractions, we got to have the same denominator, right? So just be very careful with that. A lot of students make mistakes with this, or they just kind of forget. But we've been dealing with fractions for a while now. If we need to combine these, right, we want to apply the operations, we've got to get common denominators. And the common denominator here is fairly basic. It's just going to be the product of my two denominators. So remember though, to obtain common denominators, you got to multiply the same on the numerator as well as on the denominator. Okay, so we'll do that over here, and then multiply by cosecant of y minus 1. Okay, so when we multiply that in my numerator, now I will obtain cosecant of y minus 1 minus, this is very careful, make sure you're using these parentheses, plus 1. So make sure you keep that negative, right? Because you're multiplying this truly by negative 1. And then this is all over my common factor. Now again, technically, you notice that these are a difference of two squares. So you can rewrite this as a cosecant of y, or cosecant squared minus 1, which we already know is cotangent. All right. Let's go ahead and distribute this negative. Negative, yeah. So what we can see here is now this turns into a cosecant of y minus 1 minus cosecant of y minus 1 all over cotangent squared of y, right? Because cosecant squared of alpha, or minus y, so therefore this is equal to cotangent. Well, from here we can see the cosecants are going to subtract to 0, and negative 1 minus 1 is a negative 2. So we have a negative 2 over cotangent squared of y, which by using the reciprocal identity, we can say that's negative 2 tangent squared of y, and that will be our final answer. All right, I'm going to take a quick little break. If you guys want to work on the multiple choice, go ahead and go for it. I'll just go ahead and check in for you guys. Sorry my stream did go out, so I'm not sure if I have any questions or whatever else, but I'll check in with you guys. Maya says, learning this in school. Awesome. I'm glad we are on the same page. I will be doing trig, or at least analytic trig here for the next couple weeks. Black says, which one are you talking about? Black enemy. Equals secant, right? You mean 1 over sine. I probably misspoke, but I'm not sure which question you are referring to. Artemis says they're working on trig, all issues with identities. God's say. Well, unfortunately, the homework, I'm not going to get as in depth with my identities. I will say though, if you look at a lot of my videos, I will be uploading some identity videos. within the next couple weeks. So you will see a lot more stuff coming along. But obviously on my playlist, I have a ton of videos on my old identities, that I had. But then we're going to be doing identities here for the next, probably about 3 to 4 weeks. So you'll be seeing a lot of content coming up on identities, Diner. Luta says, what grade is trigonometry in? I'm not really sure. This is pre-calculus. I have 10th graders through 12th graders. So kind of like a mixed bag. And then obviously a lot of people take trigonometry in college. I took trigonometry or pre-calculus in college as well as in high school. So really kind of a large spectrum. Zach Walker, I'm not a student, but I go to Oregon Tech. Awesome. Cool, Zach. Well, I'm happy to be able to help you out any way I can. And Pippy Head. Pippy Head. Oh, hey, how are you? Good to see you. I'm not sure what the secant of x is, what you're referring to. The 1 over cosine. I guess maybe I misspoke, or I'm not sure. Do you have videos on damped rig functions? No, I do not. Okay. Well, if you guys have any questions or you want me to address any other problems that you were working on, I don't have that much time left, but I will be more than happy to answer kind of some questions for you if I can. But I did want to kind of make a little shorter stream today, so looking to get out here in the next 5-6 minutes, and the rest of these shouldn't really take that long. But if you guys do have some questions that I can help you out with, let me know, and I'll be happy to see if I can answer them for you. All right. So, multiple choice. When we're looking at the multiple choice type of questions, basically we are, want to kind of see how can we, which identities can we use here? Well, we have cosecant of pi halves minus x. Remember that is a cofunction identity. So the cosecant is going to be the secant of x. And then times, remember the even odd for cosine, that does not change the angle, so that is still cosine of x. Obviously, we know that secant and cosine are reciprocals of one another, so that's going to equal 1. The next example, I have 1 minus sine squared of x using my Pythagorean identities, if you guys look at that. And again, guys, I don't have these up, so that's why I'm just going to refer to and assume that you have access to these identities. If you look at the Pythagorean identities, you can understand that 1 minus sine squared is going to be equal to cosine squared of x. Sine of x minus cosecant of x, we're going to have to do that work. Sorry, let me zoom in. The sine of x minus cosine of x, we're going to have to do that work on our side. So let's go ahead and do that so we can see what that one is. So right now we know what the numerator is. Sine of x minus 1 over sine of x. Let's go ahead and get common denominators. Okay, so therefore that gives us sine squared of x minus 1 all over sine of x. Sine of x minus 1 is going to give us a negative cosine of x, or negative cosine, negative cosine squared of x all over sine of x. Okay, so this gives us a negative cosine squared of x over sine of x. And then if I multiply now by my reciprocal, my negative cosines will be left out, and I'll be left with a negative sine of x. So if you multiply by the reciprocals, those would divide out, but you'd be left with that negative symbol and the sine of x. That's where I'm getting the negative sine of x. And again, just remember sine squared minus 1, that's equal to negative cosine, because sine squared of x plus cosine squared of x equals 1. So if you subtract the 1, you'd have to subtract the cosine over to the other side. All right. Number 3, simplify the expression 1 over cosine squared of theta minus 1 completely. So it looks like we'll need to get a common denominator again. So let's multiply by cosine squared of theta over cosine squared of theta. When you subtract those, you get 1 minus cosine squared of theta, which we know is going to equal sine squared of theta, all over my common term of cosine squared of theta, which is sine over cosine, which we know is tangent. Number 4, find the cofunction with the same value as the given expression, cosecant of 83 degrees. So just remember that the cosecant of, any angle is equal to the, cosecant of any angle is equal to the secant of pi halves minus theta, right? As the secant of theta is equal to the cosecant of pi halves minus theta. So now we know what the theta is. It's 83 degrees. Now, pi halves is, that's in radian form, so we won't want to convert that to degrees, so we can convert that to degrees. We're going to say cosecant of theta is equal to the secant of 90 degrees minus theta. So if we're looking for the secant, right, we're going to look at 90 minus 83 degrees, which is 7. So that answer is C. So let me just write in there. Cosecant of 83 degrees is equal to the secant of 90 degrees minus 83 degrees, which is answer C. So there you go, ladies and gentlemen. Hopefully this kind of helped you out a little bit with identities. There's a lot that goes on with identities. This was just simplifying. Really, I wanted this to kind of be like a basic, basic really kind of lesson. Didn't want to go too deep into it. Obviously in my class, we have now covered, verifying identities where we do a little bit more complicated problems. Not too much though. I kind of kept everything rather simple for my class this year. I didn't want to get, too kind of crazy with the identities, but I do know that, making sure that you guys can apply some of these basic operations and feel really good about them is going to be important for you being successful in this chapter. Knowing these, reciprocal, quotient and Pythagorean, feeling really comfortable with them. So I think I'm going to have some videos that I will be posting to help you guys be, perform very well on these kind of videos or these types of problems, because it is difficult. It is tough to really perform on these. And then I do have some extra documents that, I will provide on the membership side for those of you that are kind of interested or need a little bit more than what I can deliver just on video format. But otherwise, I think I'm going to kind of end with that. David says, reminds me of the old days of doing trigonometry, how fun it was. Trigonometry is such a Looney Tunes math. And you know what? I told my students today too, I think this was the first lesson I actually enjoyed mathematics. So I'll talk more about that maybe a little bit later, but yeah, this was my first math. I remember doing this in high school and being like, I actually enjoyed this stuff, because it wasn't your typical math that I remember doing, your typical solving equations, graphing, all that kind of stuff. It was kind of like problem solving, right? And like little puzzles, and I like that. So this is really what kind of started my journey on doing more and more math, and obviously want to pursue a career in teaching mathematics. So this was the topic that did it all, but otherwise I am going to leave it off for that, and therefore we'll get back to another live stream. Hopefully I'm looking to do one possibly this weekend, and just because we're going to have a quiz coming up, so I'll have a couple more live streams coming up. But otherwise, guys, I'm going to make this short, so I'll peace out, and I'll see you guys soon. Cheers.